Hi everyone, I'm Nicolas, working at Haulogoy. So basically we're a software company which is basically aimed towards everything that's energy related. So we're present in Belgium, in the Netherlands and in France for now. Hopefully we're going to expand even a little more. Uh, and so we're basically trying to, our ambition at least, is to try and work for the energy transition. And this is mainly by interacting with different actors of the energy sectors. And so mainly we act with retailers, with DSOs, which are basically those operating the electrical grid, and with big companies as well. So my presentation will be twofold today. First, I try to just briefly go over the use cases that we have so that you basically understand more or less what are our business cases and what we are trying to achieve. And then from there, I'll go towards the difficulties that we've had with these business cases, and then towards how we use ClickHouse in order to solve it. So how basically are we trying to help the energy transition? That's a big word, of course, but it's basically by building software solutions for the retailers. So for now, retailers are often offering some kind of very rigid product to their customers. What we're basically building is a software platform for the retailers to be able to build some way more custom offers for the clients. And then I won't go too much into the details, but just take an example to carry me through this set of slides. So for example, we're building a platform where the retailer can build a product for their clients, which is a power purchase agreement. So what this is essentially the retailer has some sort of renewable production, be it, for example, solar farm or windmill or whatever that is. And then it can sell part of the production of that asset towards its client. And of course, there can be some defining rules as to how that production is shared, for example. Here we have an example where we have 3 customers, which all of them have an agreement with the retailer to have part of a windmill, basically. And one thing that's very important to note is that what we're doing is really trying to trace the energy as well as possible. So when you're buying energy from that retailer, saying, okay, it's energy coming from a windmill, you're actually really basically consuming energy from that windmill. What this means is that we have to do all this in real time with time series data. So basically, if you're buying from a solar panel, for example, then you're going to have available energy during the day and not during the night, of course. What are the advantages for the customer? Well, first, the prices are different. So if you're consuming from whenever that panel is producing energy, then your costs are reduced. However, you still, of course, have your base product, which is the filling product. If you consume whenever there's no solar energy available, then, of course, you're going to pay more. Okay, so in this platform, we basically have, what this means is that we basically define aggregations, disaggregation, and sharing rules. So, for example, the retailer is able to build its portfolio, defining different products. And what this means is that basically we're essentially going to have to aggregate some time series. For example, if you have a retailer that has more than one renewable energy production asset, for example, windmill and a solar farm, you're going to aggregate that, for example, into production assets. Then you're going to share them, just as I mentioned before, for example, with a power purchase agreement towards a customer. And then that customer might also be an aggregation of multiple meters. For example, if you take, I don't know, a brand like Coca-Cola or whatever, there might be multiple meters because there's multiple factories and the power purchase agreement is at the top level of the company, for example. And so all of the meters will benefit from that product. For example, the power purchase agreement. So essentially what this means is that what we need to do is aggregate lots of time series, then do some sharing in between them, so build new time series, and then disaggregate all of these time series towards the end customers. For example, this is an example of dashboard that we can show on the end level. And I'm showing this because also what's important to understand is that this software platform is, the goal of this is also for the retailer to be able to analyze its portfolio, to have some insights on the cost and so on. And basically, you need to be able to aggregate everything at a day level, a year level, a monthly level, whatever, and with different interpolations. So dashboards can become actually very complex, where here it's a dashboard on the top level of the hierarchy, in which you have like, this is about 60 time series of data, which are aggregated by day, but you can, of course, aggregate by year, by month, and so on. And then you have on the top right, you have also metrics, which are basically average, maximum, minimums of lots of data. All of these are metrics based on time series data. So what this means is that for our use cases, if we want to be able to show such types of dashboards to the energy retailer, and for the retailer to be able to use the platform for his needs, we are basically, what we basically need to have is first be able to fetch time series extremely fast. So the dashboard that I just shown is, just as I said, it's basically 60 time series. And when you fetch that over a year, it's the resolution is 15 minutes. You have one data point per time series for every 15 minutes. So that's around 35,000 points for a year. So, and you need to fetch that very fast because you want the application to be responsive, of course. Computations must be done in real time. That's because we receive data from the market, from which we need to do computations. Because, of course, the retailer will invoice its clients. And so we need to be able to update our prices, our costs, our volumes for all the energy that's handled by the platform very fast. And what this means is that lots of data points also need to be stored at once. And just to take an example again, it's 15-minute resolution per time series, and a hierarchy can be tens of thousands of time series. And we want to be able to push that data very fast because whenever, for example, let's say you have a new market price available, then you want to update all your hierarchy in order to invoice the clients. And then that's tens of thousands of time series with 15-minute resolution over, for example, a year. So that's basically 35,000 times tens of thousands of data points. So that's quite a lot. So going a bit more into the technological part of things, hopefully now that you understand the needs that we have, we basically have a microservice architecture based on Python, and this has its importance. You'll see why afterwards. And it's basically an event-driven architecture where our microservices exchange with events through RabbitMQ. And then we have a PostgreSQL database that's used to store everything that's business-related or everything that needs to be organized with a given structure. Now, historically, we had timescale DB to store all of these values I'm talking about, which was an extension over PostgreSQL. But we had an issue is that while it worked quite well actually for our past use cases, because it was more real-time data with small points here and there, when the business shifted and we need to build the solution that we're building now, with basically having those batches of data I just talked before, it became way too slow for basically fetching the data. What I mean is that the dashboards, as I just showed before, if we wanted to show that over a year, for example, it was taking around 60 seconds just to load one dashboard, which is, of course, not acceptable at all. And given that the fetches were so slow, of course, the computations behind were slow as well, because in order to compute new data, you need to fetch the input data from the database. So the computations themselves were slow because of the fetch, and then the insertion part was also slow as well, for different reasons, because inserting lots of data with the timescale DB extension was kind of slow because it's partitioned through different tables and so on. So basically, way too slow. And this led us to the migrating towards ClickHouse. So we migrated, I think it was somewhere around 1 year ago. First, we were using ClickHouse hosted by Haven, and then now we're using ClickHouse Cloud directly. And so basically now we have a ClickHouse database that interacts with all the services that that handle basically the values computation and time series management. So if you follow well, basically our use of ClickHouse can be summarized in two tables, very simple. And one of them is the value table, where it's basically just holding all of our time point in the time series. So it's basically just a table where you have a reference to the PostgreSQL data time series, which is the time series reference. And then we have a value, a date, which together give you a point of a time series. And then we have a status and a computation date. Computation date is used so that we can do, well, we actually have ClickHouse views on top of it, so that only the latest computation date is shown for a given point in the database. So for example, if you have a point for a time series the 1st January, and then you compute a new one tomorrow, then of course the new one will be used and will be shown instead of the previous one. And so from this schema, how are we actually using ClickHouse? I won't have the time to go into all the different things we tried. This is not how we've initially used ClickHouse, so there's been a bit of evolutions. We noticed improvement every step of the way. So if you want to have a talk about what we did that worked worse afterwards, I'll be happy to share. But this is the final solution that we ended up using. I told before that we're using Python, and so that is relevant here because actually how we do the computations is as follows. So we're basically building the SQL queries in Python and calling ClickHouse directly from the Python client to get all the data we need for our computations. And we fetch that into the Apache Arrow format in order to avoid further transformation or overhead. And that's thanks to Polars, because Polars also supports the Apache Arrow format. So basically, this was also one of the important factor into us choosing ClickHouse, is basically that it supported the Arrow format because it allows us to do the computations into our data frame afterwards without having any overhead. So that's actually very efficient and very fast. And so from there, we have the data frame in Python, which has all the data that we want to push into ClickHouse because all the computations have been done. We have all of our time series computed. And so the insertion step goes into two steps. First, we write the data frame into Parquet format into an Amazon S3 from AWS. And then from there, a Lambda is triggered, and we're using the ease of ClickHouse to just simply insert the data from the S3, from the Parquet file. So that's very easy, actually. Now for the visualization part, which is the view, so the fetching part. Well, basically, we simply build SQL queries, and actually, pretty much, I would say 95% of the computations for the interpolation and having the right time resolution is done through the SQL queries from ClickHouse. There's very little post-processing that we need to do in Python afterwards. So basically, we just, depending on the call in the API and the interpolation and the time resolution that we want, we build the appropriate SQL queries and just query ClickHouse from Python. Afterwards, it's just a matter of transforming the data with the right DTO in order to serve our API. Small note, there's a few operations that we still need to post-process in Python, but it's very light. Now for some metric, because as I said, this is what we aim to achieve. Well, basically now our dashboards that were previously taking 60, 70, even sometimes minutes to load, can now be loaded in maximum 2 seconds, basically, in real time over 1 year. So for 60 to 70 time series, that's about 3 million data points, something like that, 3.5 million. And so it's about 2 seconds in order to fetch all that data and show it to the user through the API. So that's quite fast, actually. And regarding the computation and insertion, with what we achieved here, our solution, which might not be the best. Happy to talk also as well if someone has a better idea than what we're doing afterwards. But with what we're doing, actually, we're basically inserting and computing 300,000 points per second. So whenever we're recomputing a hierarchy, this is around what we have. And just to give you an idea, our current database is around 2.5 billion points in it. And that's the results we are achieving. And to be clear, this is with the base plan in ClickHouse Cloud, which is basically 3 replicas of a 16 gigabyte for vCPU database that we achieve these performances. Yeah, and just as a side note, for whoever's interested, if you have really a lot of data to compute, of course, the Parquet file will become quite big, and so we sometimes need to just cut that into smaller pieces. So that, for example, if you compute 1 year, we're computing month by month in order to have smaller files. So I don't know if I have time for questions or if we're keeping that for afterwards, but I think that's my 15 minutes around there.